I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand and do chemistry at home in your everyday life.
Okay, Jam, I'm very excited about this experiment. Can you tell me about what you did?
Yes, I can. This one was simple, which was cool because the past couple I just was so afraid of messing up in some way and maybe having like not the ability to redo it or something and being like, man. So I like this one was simple and I felt like pretty confident going into it. I took a penny. I actually had to get Melissa's help because I did not have any pennies. I had found like one penny, but it was really new, which apparently is not quite ideal in this.
We can talk about that too, why it does that.
Okay. So so Melissa helped me get some pennies. Mrs. Moneybags over here was able to help poor Jam. Didn't even have a penny over here. And so got a penny, some vinegar, and some salt, and put some vinegar in a bowl, added some salt to it, stirred it all up, which actually took a little bit for it to dissolve in there, and put the penny in there for 5 minutes and just let it kind of mingle around with the salt and vinegar. And
did you see any changes at that point?
Yes, to me it started looking shinier. Like the specific one I put in was pretty dull looking. And so it started looking shinier to me once I put it in the vinegar and salt. And I did video that whole thing, so I think maybe it'll be obvious if I speed that part up to see if it became shinier or if it was just immediately shinier or if it was an effect of just being submerged in liquid or something. I couldn't totally tell. And then I took it out and put it on a paper towel and left it overnight. And I did a time lapse to show any changes that might occur to the penny overnight.
And what happened when you came back in the morning?
So this morning, then, I came back out to check on the penny, and it looked the same. And I was like, dang it, what did I do wrong? And then just as a extra try to examine everything, I flipped it over, and the underside had turned green.
Nice. Okay.
It wasn't like necessarily a uniform green. It was kind of splotchy, but definitely green.
Do you want to talk about the chemistry behind that or
yes.
What? Okay.
Absolutely.
So the best representation of this is rust. What we're basically doing is oxidizing the penny, and that is the same thing that happens in rust. And if you want to know more about the chemistry of what happens in rust, essentially, you can go back and listen to our episode about rust, but essentially, there's an electron highway that takes place between the vinegar and the salt and the copper on the penny and then the oxygen in the air. And because of that electron highway, electrons are allowed to move back and forth between the copper and the oxygen. It's called being oxidized or reduced. And then a new compound is formed with the ionized oxygen and the ionized copper. Ionized means gained or lost an electron. So what you're seeing, actually even that initial dark color, is a type of oxidized copper. And then you are using the vinegar to literally dissolve it, just like we talked about how you can dissolve rust with vinegar. And that is why your penny seemed shinier.
Oh, gotcha. Okay.
And then that fresh surface of copper is exposed with the electron highway to very quickly be able to form a different oxidized form of copper that reacts with oxygen to make the green copper oxide. So they're both copper oxides, but they're different types of copper oxide. And so you get rid of one and then facilitate the occurrence of the other is what you're doing in this experiment.
Got it.
So it's a really fun one and it's really easy. I didn't love any of the ones that already existed online, so I wanted to change it and make it easier and simpler for Jam. And I did it myself on Friday night at home while I was watching an episode of Psych. And I got so excited. I did it with a bunch of different pennies to see the different things that would happen. I was into it. So
Friday night, doing some chemistry.
I know, that was truly my Friday night. So that is what I did for that. But this, because it's such a simple experiment, it lends itself to a lot of modifications, and you can do a lot with your kids. So if I was doing this with Jam or with a kid or with even an adult, I was excited about it. I would maybe do a vinegar and a water bath, both of them, or maybe plain water, salt water, vinegar, salt, something like that, and put a penny in each of them and see if they all change. And make your children or ask your children to make some guesses about what they think is going to happen. If you put these in there, what do you think is going to happen? Do you think it'll be different between the other ones? Maybe you can start with them in water and then ask if you think the same thing will happen in salt water. Do you think the same thing will happen in vinegar? It's also good to do before and afters because it can be hard to see it. Kind of what you talked about. You thought, is that just a product of it being in vinegar? But if you do a before and after, you can see the dull penny and the shiny penny, and it is different, and it's the same penny. So doing before and after pictures helps a lot. And even taking a video, because the acid works pretty quickly in terms of dissolving that dull. You can take a video and then speed it up or scroll over it with your finger quickly and see the change. And that is, I think, exciting to be able to see with your own eyes.
Yeah.
And then same thing for the time lapse. It is really cool for kids to be able to see experiments happen over time that they did. So then the next thing I would do when you take it out and you leave it on the towel. So Jam had the experience of only the underside of his turning green because it was in contact with the towel. So I think that held the vinegar there, allowing that electron highway to go longer. I had the opposite experience. I had a little bit of vinegar, I think, left sitting on top of mine. And I put it on a solid surface that I think is concrete. So I think it might have evaporated, absorbed in the vinegar quickly. So only the top of mine turned green.
Got it.
So you can set some pennies out with your kiddos, put them on different surfaces, put a different amount of, maybe you could sprinkle your vinegar salt water on top of it and see what changes there. You can also try with newer pennies and older pennies and ask if you think the same thing will happen. And actually, before 1982, pennies were solid copper. And after 1982, they became zinc coated. They're zinc in the core and they're copper on the outside. And it's actually a copper alloy on the outside. So it's not pure copper. So those will probably be slower. So then you can also, try different kinds of pennies and see if they react differently and ask your kids questions about that. And it's just a really fun one. So I think this is a great experiment. I think it's easy. It's fun. It's cool. If you have change around, you usually have change and vinegar. So something will for sure happen. And if you wait long enough, something happens. So even if you don't have the green right away, add a little bit more salty vinegar and see if that changes it. Soak the paper towel or the cloth towel in vinegar and see if that changes, and you'll be able to see changes. And I really love the idea of a time lapse because then the kids don't feel like it's just magic happened while they're sleeping, And if actually what we're going to try to do is have Jam drizzle a little bit of the salty vinegar on top and soak the towel and do another time lapse and see if we can catch the formation of the copper oxide on that surface. So I'm pretty excited about that.
Yes. Yeah. I definitely want to try it again. So I'm going to do that after we record and then leave it for the rest of the day and see if we get a better result on the top part.
That's pretty exciting. Did you have fun doing this one?
Yes, I did. And Em was actually kind of surprised because my wife, she was like, "You already done?" I was like, "Yeah, actually most of it's just going to be waiting overnight." But sometimes I'll be in the kitchen for like a while working on these experiments or trying to make sure I don't mess it up. And this one, the actual active experimenting part was so fast. And then I was like, okay, interesting. Now it's just waiting. We'll see what happens. So it was pretty fun.
So in that way, it's not great if you're trying to fill up your kids' time, but it is a fun, quick, easy one.
And it's nice because I feel like redoing it doesn't feel like a huge chore in the sense that like, oh, I have to get these ingredients back out and make this and get all these dishes dirty or whatever. It's like, oh, I could just get a few pennies and do it again if I want to. And it feels kind of fun to try it a few different ways and not feel like that's a lot of work. I feel like kids could do it again if they want to and it'd be pretty easy to hop right back into science mode.
And it happens so fast. I mean, so fast. I dropped that penny in and did a 30-second video or so and saw a change in the texture of the dull to shininess or whatever in about 30 seconds. It was a stark change. The longer you leave it in there, the shinier it'll be. But it was really cool to see that.
Yeah. That's cool.
So that's pretty much it for this experiment. I would encourage you to let your kids wonder, like, does this work with anything else? Should we try lemon juice? Should we try baking powder? Should we try Windex? What's the harm? You're just basically going to throw a penny in some kind of household product, and it's very unlikely. Maybe do a quick Google to make sure, but it's very unlikely anything dangerous will happen. It's mostly just going to be fun, and your kids will get to wonder and try things out. And I had a lot of fun doing this and was surprised at how fast it was and enjoyed it as an adult chemist. So I feel like if that's true for me, who does lots of experiments that are way more complicated, then your kids are definitely going to be excited about, or they can definitely get excited about it.
Yeah. Very cool.
Oh, that's the other thing your kids can try with different coins. I don't think the other metals would react with vinegar in the same way. It might clean it still because it should be some kind of oxidation, but I don't know for a fact about those. I didn't look into other ones. And also, a fun fact is this, I think a lot of people know, but this is the same thing that happens to the Statue of Liberty. So the Statue of Liberty is green because she is made of copper, and then it was oxidized over time. It didn't happen just overnight. It took a long time. It's pretty cool.
It's kind of funny, too, because it's like, did they know that was going to happen and they were cool with it? Or was it a surprise? And it's like, man, our beautiful copper statue is not copper anymore. It doesn't look copper.
I know. I don't know. It's very interesting. I wonder about that too. And if it would even look as good as the green if it was copper colored.
Yeah.
Well, that's it. That's what I have for you. I hope you and your family enjoyed doing this penny experiment. I know I certainly did.
And we'll see if I can get my penny to be even more green.
That would definitely be fun.
This episode of Chemistry for Your Life was created by Melissa Clooney and Jam Robinson. And we'd like to give a special thanks to E. Robinson, who reviewed this episode.